Okay, students, welcome to one and all. We will start class another 4 minutes. Totally one, two, only three students came. Yes, ma'am, you can start the class now. 5 minutes is completed.
Good morning, class. So, in the last class, I have told you about different categories of water. Okay, and this last one, the virtual water, this term has been given by Tony Allen. Okay, this you have to learn. And this virtual water is also known as embodied, or you can say embedded water. Okay, so this was I missed. Now we go further with our lectures. Now some important more points are there which I have left, like World Water Day. Since we are studying the water, and we should know ki at which day the World Water Day is going to be celebrated? So the answer of this question is 22 March. Okay. Per capita availability of India is usually only 1750 meter cube per person per year. Okay, so this you have to learn ki how much per capita availability of means the of person of India is usually having. Okay, now some more questions are there, like the irrigated area is highest in Asia. Means the Asia is usually having largest area under irrigation. And if we talk about in Asia, India is the highest country which is giving the irrigation water. Okay, so this you have to remember why the Indian irrigation is very much important. Okay, ki how much area India is contributing under the irrigation also. Okay, now in previous lecture I have told you that ki annual precipitation on the earth or the annual precipitation and including the snowfall all estimated into India is 400 million hectare meter. Okay. And this further divided into 300 million hectare meter during the monsoon season, and for the rest of the time period we are having 100 million hectare meter. Okay, so this million hectare meter is also this million hectare meter is also means converted into your kilometer cube, or you can say bcm. Okay, and this bcm is known as the billion cubic meters. Okay, and how you are going to convert this million hectare meter into kilometer cube and the billion and cubic meter, I'm telling over here. Million hectare means what do you understand by the millions? It is ones, tens, hundred, then 1,000, 10,000, 100,000. Then we are having million. Okay, so with this million value, you have to multiply a hectare meter. Okay, so over here, hectare means 10,000 meter square. Okay, and if we multiply meter with that unit, it will be kilometer cube. Okay, and if we multiply this million with the kilometer cube, sorry, your meter cube, your answer will be 1 2 3 4 5 6 7 8 9 10, 10 to the power are 10 meter cube. Okay, and if we have to convert this meter cube into kilometer cube, what we have to do? We just have to divide this 10 to the power 10 and meter cube with 1000 cube. And can anyone tell me why we over here we are dividing it by 1000 cube? Into 1000 meter. And if this will be in the cube, then your meter cube will also be in the cube. So because of that, over here we are dividing it by 1000 to the power 3. Okay, so your million hectare meter cube, when converted into kilometer cube, it will be, your answer will be 10 kilometer cube. Means whatever value will be come into million hectare meter cube, we have to multiply it by 10, because over here you can see 1 million hectare meter is equals to 10 kilometer cube, which I have shown you. So over here 400 million hectare meter will be given by 4000 kilometer cube. Okay, have you understood, everyone? So in the same way, again, what we have to do, we have to convert this million hectare meter into BCM. Okay, and over here it's billion. Okay, then again, what we have to do, 1 million into 10,000 meter cube, we are representing it in the form of this meter cube only. Okay, so over here it's billion. Okay, so we have to divide this value by billion. And what is the billion? Ones, tens, hundred, 1,000, 10,000, 100,000, then 1 million, 10 million, 100 million, and this divided by this. Okay, so 1 2 3, 1 2 3, 1 2 3, sorry, 1 2 3 4 5 6 7 8 9, 1 2 3 4 5 6 7 8 9. So these all zero will going to be cancelled, and again in over here you see this million hectare meter is going to be 10 bcm. Okay, so over here you can say 1 million hectare meter is equals to 10 bcm is equals to 10 kilometer cube. So in question, means in options, instead of million hectare meter, means total precipitation or the annual precipitation in India can be given in the form of million hectare meter cube, bcm, or kilometer cube. But you have to see the unit, and then you have to correct the answer, means you have to select the correct option. Okay, over here 4 million hectare meter, but in terms of bcm it will be 4000 bcm, and in terms of your kilometer cube also it will be 4000 kilometer cube. I hope I have made you clear about these units now. So whatever water falls on earth surface of the India, it's usually going to be convert into to annual potential flow. Okay, and in India the annual potential flow in river are usually 180 1869 bcm. Okay, or you can say 186 million hectare meter. Okay, so out of your 400 head, 186 million hectare meter will be flowing in the rivers. Okay, but due to your various constraints of the topography, or you can say uneven distribution of resources over the space and time, it has been estimated that only 1122 kilometer cube, or you can say a 112.2 million hectare meter will be present in the river flow. Okay, and out of this 112.2 million hectare meter, 69 million hectare meter will be flowing through the surface water, means whatever we can utilize, and 432 kilometer cube, or 443.2 million hectare meter will be utilized as a ground water. Okay, now moving to the next. if we see about the groundwater resources of India, which is 4,432 kilometer cube, out of this is the total replenishable groundwater. But 71 kilometer cube out of this is usually we are using for the domestic, industrial and other uses. And if we talk about our irrigations, it means ki whatever water, groundwater is there, 71 kilometer cube we are using for our domestic use. Okay, so how much water will be left for the irrigation? It will be whatever 2 miss 1 gaya 1 4 13 miss 12 gaya, then you are having 336, and over here means 361 kilometer cube water will be available for the irrigation. But out of this 361 kilometer cube of water, or we can use only the 90% of it, we can and utilize as a groundwater. Okay, so if we calculate the 90% of this 361, your answer will going to become 325. So this 325 will be your utilizable groundwater resources for the irrigation. Means we can't use all these 361 kilometer cube water, but we can use only 90% of this. And the utilizable groundwater for irrigation will be your 325 kilometer cube. Okay, so if we add this 3 to 5 plus our domestic use, because this 71 kilometer cube we are also using it for, but some for other purpose. Okay, so over here your 396 kilometer cube total utilizable groundwater will be there. But this 325 kilometer cube your utilizable groundwater for irrigation. So this you have to focus, means in option what is given or what is asked, according to that your option is going to be changed. Okay, I'm just repeating once again कि out of your 1122 kilometer cube, we are using that water, or on the surface only 690 kilometer cube. But the rest water which are flowing in the rivers, there it get percolates or infiltrate as a groundwater, and that unit is 432 kilometer cube. Okay, and this 432 kilometer cube, out of this 71 kilometer cube we are using for the domestic use. Okay, then we are having 361 kilometer cube left for our other purpose, as like the irrigation. Okay, but this total 361 we can't use for the irrigation, we can use only the 90% of it. So our value will be 320 5 kilometer cube water we can. And this is known as the utilizable groundwater resources for the irrigation. Okay, and if we add total groundwater utilization of groundwater resources, then this 325 plus 71 and 396 kilometer cube water will be there. Okay, now moving further over here, systems of irrigation. Okay, before that, one more thing I have left, कि if someone will ask you कि how much water or this groundwater contribution to the irrigation is there in terms of percentage, then it lies between the 46% to the 50%. Means in mostly this 50% water is going to be mentioned, and in that answer. Okay, and if someone asks you about how the groundwater deficient state, which state is using in most mostly the groundwater as a irrigation, or because of that the groundwater deficit uh, will occur in that state. So, your answer will be Punjab and Haryana. Okay, this is very important because in these stated there is a groundwater deficit. Okay, then we are having the system of irrigation, means how we are going to arrange or classify the system of irrigation in India. Okay, so this system of irrigation is usually the available water resources for the crop production, which are usually as a rainfall, or you can say the canal water or the groundwater, means everything is going to be included in that irrigation, canal water and ground water. Okay, then this system of irrigation is divided into two types: the surface irrigation system and the groundwater irrigation system. If we talk about the surface irrigation system, so it is whatever water present on the surface, it might be diverted from the rivers and stream where they are flowing, means that can be known as the diversion system, means whatever water is flowing into the rivers or the streams, we are diverting that water of rivers to the our crop side, okay, or our field side. Okay, and a second thing, we can also do what whatever flowing water are there here, we are stored as a upstream side by the constructions of any barrier across the flow, means some water is flowing through this and we have constructed any dams or like reservoir over that. So now whatever water beside this construction obstruction is there, we can now use that water for our irrigation in the crop fields. Okay, so this surface irrigation system is divided into diversion system, and the second one and will be the reservoir or the tank system. Okay, and this tank irrigation and is usually stored irrigation scheme which utilizes the water stored on the upstream side, and there we can make a earthen dam which can also be called as a bund, and these other ones reservoirs are known as a tanks. Okay, now nowadays this tank water are usually declined. Okay, so we should, so we should know about the factors in the decline in the tank irrigation, and why there is a decline in the tank irrigation. And I have told you also which state is using very much this tank system, or you can say the tank water for irrigation. So your answer will be the Andhra Pradesh, because in that this tank irrigation is very much and play an important role. Okay, so there are several reasons for the decline in the tank irrigation, that we are not maintaining the tank system due to major thrust we are giving on the major and medium irrigation and projects. Okay, means before the independence, hence this major and my medium irrigation projects was not very prominent, but after the independence this major and medium irrigation projects and came into role, and because of that we are less focusing on this tank irrigation system. And also there is the destruction of the forest, you can say, or the excessive grazing of catchments area of the tank, and the cultivation of the four source areas of the tank, and because of that, and there is an excessive soil erosion and the silting of tanks is there. If we are destructing the forest, and then our soil conservation will not be there here. If forest is not there, or that in short it means that the trees will not be there, and you know that the trees are using for the binding the soil. Okay, so if these forests are going to be cut, or we can say if we are allowing our cattle for grazing to with their food or fit, you can say, the soil is also get eroded, means we should not allow overgrazing in also. And this catchments area of the tanks are also we are using in means we are overusing that, and because of that there is excessive soil erosion and the silting of the tanks. And also this was the first reason, this was the second. Now the third reason, which is very important for the this decline of the tank system, because the farmers gave preference to the more stable alternatives. And what will be the more suitable alternatives? And these are the well system. Okay, so the farmers are using preferring this well system more. And because they this well irrigation is relatively uh, stable than our tank irrigation system, because frequent droughts outs will occur after the independence, and that leading to the no water in the tanks. Okay, now we focused on the groundwater irrigation system. So I told you about, if someone asks, then you have to say that the 50% into of total irrigated area in India is gets its irrigation from this source only, this groundwater source. And if we talk about this advantages of this, means ki why this well irrigation there is a decline. This diversion is usually a first step in the surface irrigation system, and then the second step means that become the making the surface irrigation system more stable. Then we are making the reservoirs on that. This will be the second step. In the same way, so I have discussed about why this surface irrigation system or the tank irrigation system is declined. And now I am telling you why this open wells or the dug well, means the groundwater irrigation system, increased in India. Okay, since adequate availability of the groundwater is there in the state like Uttar Pradesh, Punjab, Bihar, and your Haryana, Punjab, and Haryana. These are the states where there is the adequate availability of the groundwater. Okay, and after the independence, we have focused on the irrigation and mainly, and since because of that, the availability of modern technology is also for drilling wells and the lifting water is increased. Okay, this modern technology he is also increased after the independence. And the third one is that the this system increased the crop productivity and higher monetary returns from the well irrigation due to the perfect control over the water. And there is an absence of the drainage problem, means in the tank, if we talk about, there is a problem of the drainage also, but in this well system, if we talk, there is a less problem of the drainage. And because of control over the water, we can use these wells safely. And also there is a financial support out we are getting from modern on this private and government agencies for development of wells also after the independence I am talking. Okay, ki the private and government subsidies are giving to the farmers for go more and more well construction. Okay, and there since there is an uncertainty of irrigation and through the tanks and other sources due to a low and erratic rainfall, this surface irrigation is usually we are getting through our rainfall, which whatever rainfall occur in that area, that is going to be stored, and then we are going to use that. Okay, but in groundwater, this there is a no such constructions are means constraints are there, or for means the rainfall is not very much important, playing an important role in the groundwater. And also there is no silting problem, you can say, or your maintenance is not that much high in the groundwater. Means we just have to dug the well, and we have to use that water. Okay, so now this again, this well are usually of the two types, you can say, the open well or the dug wells. In this only we dug out the wells up to the water bearing strata, means the layer strata over here means the layer, means whatever layer of soil is there, we dug up to where we are able to see the water. This is known as the well or the dugout well. But in tube or bore wells, what we are doing, we sunk by inserting one pipe below the groundwater, and then through water bearing and non water bearing stratas are there, means through that pipe is grown through into the deep into the ground surface, and whatever means the place where the water strata is there, till that we insert. And this again, this tube or bowl wells is of two types, the cavity type and the screen type. Okay, only this much you have to understand, nothing more to understand in this. Now there is means ki by increasing the use of this groundwater, or what happens in India, we have to focus that also, ki we means after the independence, you know, I told you that the groundwater use is increases is, and now one state is going to be reached at where in 2000, that this groundwater irrigation potential will increase from 6.5 million hectare in 1950s to in 2000 it increased up to the 40 million hectare. Okay, so see this how much time, if we say it's six times become greater. Okay, now because of that, the present rate of annual gross withdrawal all is less than the 50% of available groundwater for irrigation. And overuse of this groundwater, there is a now decline in the groundwater or the water table. There is an decrease or decline in groundwater levels, because we have the reasons are we have decreased the level of water in wells. The second thing is that we have increased our pumping cost, and there is a higher consumption of energy, because since the water table is going down and down, and so we have to increase our energy. So the water liftment or whatever things are there, or the energy required for or taking out the water from the depth, it's also increasing. As the water table decreasing, the energy is increasing day by day, so there is a loss of lots and lost cost will be there. And also, if we say, there is a failure of the wells and tube wells also who occur. So now what we have to do, we have to use our surface irrigation, means the surface water, as well as we have to go for something artificial groundwater recharge. Okay, this groundwater recharge is very important, because we are not earned recharging our groundwater. We are just using the groundwater more and more, but we are not giving or we are not focusing in how we are increase the groundwater. So we have to focused on some groundwater recharging also. Oh, and the first point over here that should be, we have to surplus the monsoon runoff. Means key whatever monsoon the rainfall is occurring, we have to increase that through the runoff. And we also, we can also use our canal water during the rainy season. Means in rainy season we should not use the groundwater. At that time we just focusing on the use of the canal water, so that and and whatever water is flowing or runoff is there, we should use that water mostly. Okay, then the third point is that we should also treat our sewage water. Means because as you all know, in the sewage also, so we are using lots and lots water, so we should use that sewage water. By treating it we can use that water for the irrigation also. These are the points. Next, there is one term, conjunctive use of surface and groundwater. Okay, so this conjunctive use management is usually the multi source water, which can be defined as the management of multi water resources in a coordinated operation. Then that total water yield of the system over the period of time is exceeds the sum of water yields by the individual component. Means if we are using only the surface water, then it will be only 680 kilometer cube, and there may be some demerits of that surface irrigation. And if we are using this groundwater, so you all know that out of 433 kilometer cube, the utilizable is only 396 kilometer cube. And also we are so much focusing on the groundwater that the groundwater level is decreasing day by day. So we have to use both the surface and irrigation system, or you can say, hey, the different water sources in coordination. And if we use this different water sources in coordination, and then this total water yield is going to be increased. And total water yield of the system is also increased with the period of time. And this total water will be always greater than the sum of individual source. Means over here we are using different water sources, but if we use the individual source, so this total water source yield will be always greater than. So conjunctive use over here, it just means ki we are using different and or multi water resources together. This term usually asks in the exams, that is our supplemental or life saving irrigation. Okay, so this supplemental or life saving irrigation, it simply means that one or two irrigation we are providing into the crop during its whole life cycle. And this one to two irrigation we are providing at prolonged drought condition. Means because it at that, and he that crop is facing prolonged drought condition, and if we are not giving this one or two irrigation to the crop, then the crop failure will occur. Okay, so this term supplemental or the life saving irrigation and is also very important. Okay, now moving to the next topic, if we say these are the terminologies which usually occur, and this duty of water and you can say the delta of water is very important. So one by one we will be focusing on all the terms. First of all, we are having the first term, we are having gross command area. So gross command area, it simply means ki whatever total area present, or whatever the India is bounded within in this irrigation boundary of a project, or you can say a or in other words also, which can be said as economically irrigated it without considering the limitation of quantity of available. Means in that we are not focusing ki how much available water is there here. That area will be used as the word gross command area. Okay, and usually this gross command area includes the cultivable as well as the non cultivable area. So cultivable area simply cultivable area simply means where the crops or anything in the tree or any something is cultivating on the soil, that is known as the cultivable area. And non cultivable area as are usually like your roadside, your building on which the buildings have occurred, the hospitals, or you like these things are there, they all are known as your non cultivable areas. So this gross command area in simply means the boundary of India, and the area within the boundary of area is known as the gross command area. Then we are having in the culturable or cultivable command area. So this culturable or cultivable command area, which is also known as CCA, it is that part of gross command area in which the cultivation is possible, and it is the actual area under the irrigation. Means we don't have to focus ki whether the water is available to irrigate that area or not. Means that area we have to irrigate, that is known as the culturable command area. And in this the postures or whatever the fallow lands are there which can be brought under the irrigation are also included. But uncultivable this populated area, the ponds are there, reserved forest are there, roads are there, that is not going to be included. And that ponds, forest, or the roadside, that will be included in gross command area in by including its CCA also. Then we are having the intensity of irrigation. So actually the intensity of irrigation can be defined as when water supply from the reservoir is not adequate. Okay, they and only a certain percent of CCA is brought under the irrigation seasonally. Okay, as you know that this CCA, I told you that how much area to be, means how much available water is there to irrigate that area. This we have don't have to focus during the cultivable or cultivable command area. Whatever area or the land is there which it can be used as a cultivation of anything in that area is known as a culturable command area. But these all culturable command area we can't irrigate it seasonally. Means all the CCA is not going to be irrigated it, but some area only will get the adequate water. Okay, so the intensity of irrigation is there ki the actual irrigated area during a crop season, and this So the intensity of irrigation will be the actual part of CCA which is brought into irrigation and divided by the net CCA, whatever or cultivable command area is there, or that is known as the intensity of irrigation. And if we multiply it by 100, then it will be given in the terms of percentage. Okay, then we are having, and this will be this intensity of irrigation will be calculated for season also, means for rabi, kharif, zaid, like this also we can calculate this intensity of irrigation. And if we are calculating this intensity of irrigation for annual, means in 1 year how much we are giving in actually we are irrigating that area, divided by the total cultivable command area into 100, then that will be known as the annual irrigation intensity. Okay, now we are having the net and gross sown area. Okay, so and also this annual irrigation intensity, if we talk about your formula, so it can be given as there's the gross irrigated area, gross irrigated area divided by the total CCA, cultivable command area, into 100. This annual irrigation intensity in, means I have told you the definition what does it mean, but this will be your or this formula which can be used for calculating that. Okay, then we are having net and gross sown area. If we talk about this suppose we are taking the two crops and that are grown annually on certain area. Okay, if this area is added to the area sown only once, then that will be called as the net area sown. And if we get it what is called the gross sown area or the total cropped area. Okay, means if we talk about ki how since I have given one example ki in 1 year we are taking two crops on the same land. Okay, so if someone will ask you what is your net sown area, so we will only calculate our field, means whatever field we are having we can and give the area of that field, and that area is known as our net sown area. But if we if someone will call you ki how many area you have taken in once in 2 seasons. Okay, so that area will be known as the gross sown area. Okay, the total cropped area will equals to the gross sown area, and this gross sown area is equals to net sown area and plus whatever or we are sowing more than once. Okay, so this is very important कि the total cropped area is equals to your gross cropped area, means this total totally how much area you have given under the cropping. Okay, so that is known as the gross cropped area. But if someone asks you about the gross cropped area, how you are going to calculate this gross cropped area, so whatever net sown area you are having then in that net sown area we will be adding in the area sown more than once, whatever area we are sowing for more than once, then that will be added again and again. Suppose we have 1 hectare land, and in one season, in kharif season we have taken, and in this 1 hectare, in all this 1 hectare we have taken one crop, and then again we have taken in rabi he whole cropped area for 1 hectare, and then again in Zayed also, oh, we are taking one crop. So over here our net sown area will be 1 hectare only. but our gross cropped area will be 3 hectare, because we are actually sowing 3 times on that area. Okay, and if we are not taking in Zaid any crop, then our gross crop area will be 2 hectare. So like this, whatever area we are sowing more than once, that going to be add again and again. Okay, I hope I have made it clear. So next we are having net or gross irrigated area. In the same way, whatever or area we are sowing, then in the same way, whatever area we are irrigating actually, okay, then simultaneously your answer. I have just made you, if area irrigated only once during a year, then that area is known as the net irrigated area, and if this added to the area irrigated more than once in a year, then it will be known as the gross or irrigated area. Since now we are having area to be irrigated, okay, actually proposed area for irrigation at any one time is called as the area to be irrigated. Okay. And this area to be irrigated can be calculated as the cultivable command area into intensity of irrigation. Okay. By multiplying these two, cultivable command area and the intensity of irrigation, we can be getting area to be irrigated. Means at once what area we have to give irrigation. Okay, then we are having the this nominal duty. This term nominal duty is actually whatever area we are irrigated it, and then we are making the ratio of that to the mean supply discharge during the base period. Means we know that I have to irrigate this much area to be irrigated. I have calculated ki I have to who irrigate this much area, but what is actually our water discharge is there, or the mean supply.
Hello, madam. Hello, hello, madam.
Hello.
Yeah, yeah,
Hello.
yes, ma'am. Your voice is muted up to now.
Okay, okay. I just unmuted it. Is it okay? Till where you have understood? I will repeat again.
Students, please ask the ma'am.
Net, net and gross irrigated areas up to there we have understood, madam. Area to be irrigated.
Okay, from area to be irrigated. Okay.
Yes, ma'am.
This area to be irrigated means proposed area means how much we are proposed the area for the irrigation at any one time. In one time how much area we have to who irrigate. We usually decide it previously, okay, and that is known as area to be irrigated. And this area to be irrigated can actually be calculated as the culturable command area into intensity of irrigation, okay. This is known as to be area to be irrigated. Then we are having the nominal duty, and in nominal duty it's usually the ratio, means whatever area we have to area to be irrigated divided by the mean water supply, or you can say the mean supply discharge during the base period. Then that is known as the nominal duty. He means we have decided कि, okay, this much area we have to irrigate, but we should have our means we know our water volume also, no, or how much water or in volume we are available. Well, with that, so accordingly we are giving the discharge to that area, okay. So this is known as the nominal duty. And then we are having nor watering, sorry, core watering, core depth, and the core period, okay. This core watering simply means that every crop water requirement and is not uniform all through the base period. Mean at one time some crop at one stage it required had minimum water, but at other stage of the crop that will require the maximum water, and based on that only we irrigate the different stages of water, okay. So this first watering is known as the core watering, and whatever at whatever depth we are applying that irrigation, that is known as the core depth. And then we are having core period. Then this is the part of the base period we will discuss later. This core period is a part of the base period during which we are applying the core watering, okay. Then it is known as the core period. Then we are having the palco. So this palco is the first irrigation we are providing to the land before sowing of the crop, okay. Means we are not sown any seed or anything. Before sowing whatever irrigation we are providing to the land, that is known as the palco. And this type of irrigation, or this first irrigation, is usually for the proper seed germination and you say for the seedling establishment, okay. Then we are having crop period. Means so this crop period means the duration in days. Means this crop period is usually we getting in a days, is from sowing of that seed of that crop to the uh, or the planting to the maturity, okay. Eh, so this crop period is from sowing to maturity only, okay. This is very important. But this base period is usually it refers to the entire duration of the crop. And this base period is also will be given in a days, कि whatever irrigation for preparatory cultivation we are giving to the last irrigation. Means this is usually in terms of your irrigation, but this crop period is usually from seed to plant till the maturity of the crop. And but this base period is usually including your palco also, Oh, which is the first irrigation before sowing, and that is before sowing means, because why we are giving that irrigation, we are giving for any preparatory cultivation. Okay, till the last irrigation is known as your base period. Okay, and this core period is the part of period, means in one irrigation, and how for how much time that irrigation is provided, and that is known as the core period. I hope all these periods you have understood. I'm repeating once again, the base period is usually including the palco. Palco means the first irrigation which we are giving for the preparatory cultivation, means for the seed germination and the seedling establishment. This palco plus the last irrigation, and at what time we are giving the irrigation, these are usually given in a days also, and crop period is also given in a days, but from the is sowing, means when the seed is sown to the maturity, then that is known as the crop period. And this core period is usually the part of your base period. Okay, a part of the base period means in one irrigation. Okay, whatever this core watering, that is the first watering or the first irrigation is there here, and for how much time we are watering that land, that is known as the core period. Then we are having our next term, delta. Okay, and this delta is you actually your total depth of water, whatever the crop required during its duration. And okay, duration means your crop duration, and in the field, whatever depth of water they are required during and usually over here it should be, I have written delta is given as a total depth required, and that total depth required is equals to the number of irrigation we are giving into depth of water at each irrigation. Okay, then that will be known as delta, and usually this delta is given by centimeter. This delta is usually given in terms of centimeter also. The centimeter can be converted in meter and millimeter also, but usually it comes into centimeter. And this delta is also denoted by December, like a triangle. Okay, and if you means seeing in a detail, so delta is actually whatever volume of water we are providing into the crop during its whole base period. Means base period means whatever the first irrigation to the last irrigation, and divided by the area of that crop. Okay, so this you can say as a delta, and usually since you know this delta is usually in the means volume will be in the meter cube and area will be in meter square, then your answer will be in meter. So volume by area is equals to, that unit will come into meter, so delta unit will be in meter. Okay, but now we are having second term, this is the duty. Duty of water is actually it's a ratio, means whatever area of crop irrigated and whatever quantity of water applied to that crop. So in a simple way, a delta is equals to 1 upon duty, means these both the terms are reciprocal to each other. Okay, since I have told you this delta is usually volume or the quantity of water divided by the area, but this duty of area, water is equals to the area to be irrigated, it divided by the quantity, and that quantity will be in a terms of meter cube, or you can say simply as a volume of water. Okay, now over here we have one relationship between this delta and duty. So how you are going to calculate any volume? that volume is going to be come into 8060 sorry 864 86,400. Okay, how this is going to be come, I will be telling you. You know that during a base period, this base period I am donating it with the b. Okay, and and that base period will be come into in 1 day. Okay, so this in 1 day means suppose we are having 120 days crop, so in 120 days crop of water requirement, that water requirement for 120 days we have to calculate. Okay, so how we are going to calculate whatever days are there, that will be multiplied by 24, because in 1 day we are having 24 hours. Okay, and that 24 hours is going to be convert into minutes, and that minutes is going to be convert into your seconds. And if we multiply all these together, then it will going to become as a 86,400. And this b is for whatever days are there for different crops, in meter cube. Okay, then we are having area. Usually this volume we are calculating for 1 hectare. So you know that in 1 hectare we are having 10,000 meter square. So this usually we are donating with 10 to the power 4. And if we see over here, so this after cancel your zero, it will going to become as a 8.64 or and d. Okay, and over here this d is usually what means whatever that depth will be there, which means whatever volume means the area to be irrigated, like this, whatever this d is going to be come. Okay, in next class I will be discussing the question based on this, then it will be more clear. Okay, for your clarification I am discussing one question over here. Okay, suppose one question is there ki the total depth of water application for a crop of 110 days, and base period is this, your 110 days period is 80 centimeter. Means over here you are getting your delta means depth 80 centimeter. Then what is the duty, what is the duty of water? So how you are going to calculate over here? As you know, this delta is equals to 8.64, and this d is for duty of water. Okay, and over here it should be with b. So what you are going to do, this depth will be going over here, and this delta is going to become over here. So your d is equals to 8.64 into, as you know, this base period is equal to 110 days divided by, and over here this depth is also giving to us. Since this 8.64 is into the meter, as I told you, so we have to convert this centimeter also into meter. For converting by converting it, it becomes 0.80, and after this calculating this, we will be getting your 118.8 hectare cubic Okay, this cubic per second, and this will be your unit of the D, hectare cubic per second. Okay, because as I told you, this volume we have calculated by converting into it seconds. Okay, so you have to remember this thing also, कि your delta unit will come into the centimeter, but your duty will be like this, area upon volume, and this over here, this volume is usually cubic meter per second. Okay, so this area, for area we have given hectare, and then per cubic second. Okay, that will be denoted by the -1. Okay, so I'm stopping over here. The rest thing we will discuss in the next class. Okay, any doubt you are having, you may ask. Okay, then thank you class, have a nice day.
Thank you, students.